Well, good morning. This is Halloween, 11:01 on the Tuesday, the 31st of October, 2017. Supposed to be linear algebra class, and right now I'm the only one in the room, so hopefully some more students will be coming in sometime. I guess they're trick-or-treating. I don't know of any major announcements before we get started. As far as I know, my office hours should be fairly normal now, at least for the foreseeable future. On Mondays and Wednesdays, I have office hours from 3:15 to 5:15, and on Tuesday, Thursdays, 12:15 to 1:15. No, I'm sorry, 1:15 to 3:15, sorry. And then on Fridays, I'm on the Birmingham campus, 7:45 to 11:45, when we don't have meetings. And I don't know of any coming up this Friday, but we don't know yet. It's not Friday yet. So, where we left off last time, we're in Chapter 3, Determinants, 3.2, Determinants of Elementary Operations. And we were just getting ready to start Example 4. So since there's no one here to ask any questions, I would say, are there any questions on anything we've done so far? But since no one's here, we'll just go from here. Now, my hands are just about frozen, not quite, but I mean, really cold in here. Here's a matrix A. Get my pen set up. If it'll set up, there we go. Okay, find the determinant of this matrix A. This matrix A is 1, 4, 1, 2, -1, 0, and 0, 18, 4. Okay, so find the determinant. Okay. Now, one of the first things generally to do is to look at the rows in the column to see if any ones are multiples of the others. Now, 2 by 2 is going to be really obvious. In a 3 by 3 and higher, it's not always so obvious because you could have any combination of linear combination of the of one or two rows to make the third one, and it's hard to see those, okay? Sometimes it's easy, but in general not. Well, first row, second row, third row, nothing, no multiples there. First column, second column, third column, no multiples there. So we just begin. Now, what's the general rule or procedure for finding a determinant? Well, my rule of thumb, and I think the book suggests this as well, is look for the column or the rows with the most zeros in them. Well, you only have 2 zeros in the matrix, and they don't share either a column or a row, so pick either the second row, third row, or first column or third column. That's where the zeros are, okay? And frankly, just because of the size of the numbers, I would tend to pick the first column. Okay, so since I'm going to pick the first column, I'm just going to draw a little line through it because I'm going to use the first number. So let's do it. Find the determinant of A. The determinant of A would then be, we take that first entry, the 1, it's in a positive position, plus, minus, okay. So it's a positive position, so it's just 1 times the determinant of what's left when you wipe out that row in that column, and the determinant of -1, 0, 18, 4. Okay? I'm going to write this out in gory detail. Normally I'd already do that determinant. Okay, then we'll move to the second entry in that column that I chose, and I chose the first column, so we'll go to the 2. But that 2 is in a negative position. So I'm going to go -2 and we'll wipe out its row and column. Already wiped out the column. So that's going to be the determinant of 4, 1, 18, 4. Okay? And then the 0 won't contribute a thing, so we don't have to worry about that. So what we have here is 1 times negative 4 plus 0, minus 0. It doesn't matter what you say. That's a negative 4. Minus 2 times 16 minus 18. That's a negative 2. Well, look at that. You got negative 4 plus 4. That's equal to 0. Its determinant is 0, even though there's not a row or a column in common. Okay. Now I forgot that we were doing our this other way of doing it. On a simple matrix like that, it was real easy to do. Let's do it the way the book is suggesting too, by row reducing. So let's go back and do that as well. Okay? So I'm going to erase this, that, and this. Okay? Now, in this section we're doing elementary row operations. I forgot they probably wanted us to do it that way. Again, I'll look at the same things. Okay? I want the row or column with the most zeros in it, and again, you have the second row, third row, first column, or third column. But, again, because the numbers are pretty simple, I'm going to go with that first column just like I did before. I'm going to do one row reduction step here. I'm going to do minus 2 row 1 plus row 2. And that's going to be the new row 2. Alright, so that would be, you're keeping the first row, 1, 4, 1, and then do the row reduction here. Negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 4 is negative 8 minus 1 is minus 9. Negative 2 times 1 is negative 2 plus 0 is negative 2. Okay? And I'm happy with the way the third row looks already. 0, 18, 4. Okay? So there's a row reduced matrix, just one step in that. And by the way, just as a reminder, when you do add a multiple of one row to another row, that doesn't change your determinant at all. If you exchange two rows, you negate the determinant. If you multiply or divide a row by a non-zero number, you multiply or divide the determinant by that same non-zero number. But adding a multiple of one row to another row, which is really the one we use almost most often, that doesn't change the determinant any. So the determinant of this reduced matrix is going to be the same as the determinant of the first one. And that's really easy to do because now the determinant of A is the determinant of this matrix, and that is going to be 1 times, wipe out this, wipe out that determinant right there. And that's going to be a minus 36 minus a minus 36, which is plus 36, equals 0. Okay. Which was easier? I don't know. They're both pretty easy. Okay? I kind of like, especially on a 3 by 3 like this with a couple zeros in them, the row reduction. I mean, the finding the determinants by cofactors and minors and stuff, though we didn't call them that. That was pretty easy to do. This one, you had one easy row reduction step to do, which we did, and then it was just doing one small 2 by 2 determinant, and you had your answer. So, I don't know. Both of them pretty easy. Okay? The other thing, we didn't even have to do that, now that I read what the book said. once you do this reduction, you notice that the second row and the third row differ only by a factor of -2. So as soon as you saw that, you could say that's a 0 without doing the determinant at all. Okay, so I missed that one. So busy doing the steps, I missed the forest for the trees. Okay. Now, they say at the top of page 116, in example 4, you could have obtained the matrix with a row of all zeros by performing an additional elementary row operation. But what's the point? You didn't need to. Okay? So, but if you had done that, it says this is true in general. A square matrix has a determinant of 0 if and only if it is row or column equivalent to a matrix that has at least one row or column of 0 consisting entirely of zeros. Okay? So now we have two methods, general methods for evaluating determinants. Okay? Of these, it is usually faster. Of these, the method of using elementary row operation to reduce a matrix to triangular form is usually faster than the cofactor expansion along a row or a column. If the matrix is large, then the number of arithmetic operations needed for cofactor expansion can become extraordinarily large. Okay? For that reason, most computer and calculator algorithms use the methods of involving elementary row operations. And the following table shows the number of additions plus subtractions and multiplications plus divisions needed for each of these two methods for matrices of order 3, 5, and 10. So matrix order 3, a 3 by 3 matrix. If you do cofactor expansion, you have 5 additions, 9 multiplications. So that's a total of 14 steps. Doing row reductions, you have a total of 15 steps, 5 additions and 10 multiplications. So for a 3 by 3 cofactor expansion, yeah, it's a little shorter and easier. But when you get up to just a 5 by 5, I mean just 2 more rows, 2 more columns. Cofactor expansion, 119 additions, 205 multiplication, so a total of 324 operations, whereas row reduction, 30 and 45, which is 75. I would say you made significant improvement there. A 10 by 10, huge matrix, by the way. Cofactor expansion, 3 million, almost 4 million additions, better than 6 million multiplications. That's 10 million almost operations. Whereas row reduction is still big numbers, but nothing like that. 285 additions, 339 multiplications. So, in fact, the number of additions alone for the cofactor expansion of an n by n matrix is n factorial minus 1. Because 30 factorial is 2.65 times 10 to the 32nd, even a relatively small 30 by 30 matrix would require more than 10 to the 32 operations. If a computer could do 1 trillion operations per second, it would still take more than 1 trillion years to compute the determinant of a matrix using cofactor expansion. Yet row reduction would take only a few seconds. Okay? That's a big difference, a huge difference. So when evaluating a determinant by hand, you sometimes save steps by using elementary row or column operations to create new row or columns having zeros in all but one position, and then using the cofactor expansion to reduce the order of the matrix by 1. So let's do the next example. Sorry. This room is cold. I've had a big class to first, a medium class second. I was getting cold in it, and now with nobody in here, it's pretty chilly. Here's matrix A. Negative 3, 5, 2. 2, negative 4, negative 1. Negative 3, 0, 6. Okay? Now, many ways to approach this. Remember, now they want you, oh, they didn't say how, but a 3 by 3, it's a toss-up almost, which way you want to go. Looking at this matrix, there's 1 0, that's in the third row, second column, okay? That's all. But, looking at the matrix in every which way you might want to look, if you multiplied 2 times column 1 and added the column 3, you're going to get a 0 right there. So, let's do that. 2 times column 1 plus column 3. Okay? Let's do that elementary column operation. Okay? So we're leaving the first column alone, negative 3, 2, negative 3. Leaving the second column alone, 5, negative 4, 0. The third column now becomes 2 times negative 3 is negative 6 plus 2 is negative 4. 2 times 2 is 4 minus 1 is 3. And 2 times negative 3 is 6 plus is negative 6 plus 6 is 0. Okay. So just that one column operation, elementary column operation, we've got the matrix with a single entry. One row has a single entry and 2 zeros. So we can take that and now do cofactor type thing. This negative 3 here is in a positive position, plus minus plus. So that's going to be the determinant of this matrix A. Because remember, row or column operations of adding a multiple of one row to another or one column to another do not change the value of the determinant at all. So this is going to be negative 3 times the determinant that's left here. Wipe out the first column, third row. Okay? And that determinant you have left there is 15 minus 16. So that's a minus 1. Okay? 15 minus a positive 16. So 15 minus 16 is negative 1. So the determinant here is 3. Okay? That wasn't at all hard to do. And they'd make it seem more complicated than it is. And you get positive 3. No sweat. All right. 3 by 3 is not too hard, either way you do them. But this is certainly easy to do. One row operation, or column operation, elementary column operation, that doesn't change the determinant any, and then determine the determinant of the resulting matrix. Okay. Example 6, going to take a little more work. Okay? Because it's a 5 by 5. Okay, let's see about that. Find the determinant of this one. Here's A. Okay? 2, 0, 1, 3, negative 2. 2, 0, 1, 3, negative 2. Okay? Negative 2, 1, 3, 2, 1. Negative 2, 1, 3, 2, 1. 1, 0, negative 1, 2, 3. 1, 0, negative 1, 2, 3. 3, negative 1, 2, 4, negative 3. 3, negative 1, 2, 4, negative 3. Let's get it right. Yeah. And 1, 1, 3, 2, 0. 1, 1, 3, 2, 0. All right. If a 5 by 5 wasn't bad news enough, next bit of bad news, there's only 2 zeros in the entire, 3 zeros in the entire matrix. And the good news is, look where they are. The second column, 2 of them are in the second column. And look at those other numbers in the second column, a 1, a -1, and a 1. Boy, those are going to be easy to do row reductions on those. Okay? So basically, it looks like to me, add row 2 to row 3 and see what you get. Row 2 to row 3. Okay, that's going to wipe out that one. All right. Big matrices take a lot of steps, and a lot of the time is spent copying stuff down. 2, 0, 1, 3, negative 2. Negative 2, 1, 3, 2, 1. 1, 0, negative 1, 2, 3. Okay, the new row 3 is going to be row 2 plus row 3. That's going to be a 1, a 0, a 5, 6, and a negative 2. Okay? Next step will be minus row 2 plus row 5. Said that wrong. It's row 2 plus row 4 was that first step. Okay. Minus row 2 plus row 5. So minus a minus 2 is 4 plus 1 is 5. Minus 1 plus 1 is 0. Minus 3 plus 3 is 0. That's some good news. Minus 2 plus 2 is 0. That's some more good news. And minus 1 plus 0 is minus 1. Oh, lucked out there, didn't we? All right. So not only did we eliminate all but one, zero out all but one entry in one column, we also wound up zeroing out 3 entries in one row. So, just to keep this a little more honest, okay, is I'm going to take, this is my key here, so I'm going to wipe out that row and that column and that row, okay. Now that's in a positive position, so that's just going to be a 1. So the determinant of this matrix A is going to be 1 times the determinant of what's left over. Let me write that down. 2, 1, 3, negative 2, negative 2, 3, 2, 1. Oops. That was the row I was using, so mine didn't go all the way through, so I messed up there. So the next one is going to be 1 minus 1. Ooh. So I'll pay attention to what I'm doing. I get off. 1 minus 1, 2, 3. 1, 5, 6, negative 2. And 5, 0, 0, minus 1. Ugh. It's cold, my nose is clogging up on me now, sorry. I am having trouble seeing something here. Okay, we added the second row to the fourth row. New fourth row is 1, 0, 5, 6, negative 4. Okay. Let me go back and check my original. 2, 0, 1, 3, negative 2, negative 2, 1, 3, 2. Ah! That's a negative 1. Man, just little things can really cost. That's a minus 1 there. Okay, that's going to change matters. Let's just check the others and see, make sure I didn't do something else dumb. 1, 0, minus 1, 2, 3, 3, negative 1, 2, 4, negative 3, 1, 1, 3, 2, 0. Okay, that's right. So the first thing we did was add row 2 to row 4, and that gave us a 1, a 0, a 5, a 6, and a negative 4. Okay. So okay. Then we did minus row 2 to row 5. Minus row 2 plus minus row 2. I said minus 2 times row 2. I blew that one. Minus row 2, that would be 2. That's a 3. Okay. I knew something was bizarre. Oops. Okay. No. All right. Minus row 2 plus row 5. That's 2 plus 1 is 3. Minus 1 plus 1 is 0. Minus 3 plus 3 is 0. Minus 2 plus 2 is 0. And that's minus a minus 1 is a plus 1. Plus 0. Okay. I think I've got it right now. All right. So let's make those corrections that I found up above. Two, 1, 3, negative 2, 1, negative 1, 2, 3, 1, 5, 6, negative 4, and then a 3, 0, 0, 1. All right. Phew, wow. Okay. So that's our new matrix now. Okay. Well, since that went so well last time, let's do minus 3 times column 4 and add it to column 1. So minus 3 column 4, add it to column 1. Okay? And let's see what that gives us. Okay, so we're going to wipe out let's just do that first. Okay? Minus 3 times column 4. Minus 3 times 2 times minus 2 is positive 6, plus 2 is 8. And then we'll have a 1, 3, negative 2. Minus 3 times 3 is minus 9, plus 1 is minus 8. We'll have a minus 1, 2, 3. Minus 3 times minus 4 is positive 12, plus 1 is 13. And then we have a 5, 6, negative 4. And then we have a minus 3 times 1 is minus 3, plus 3 is 0, 0, 0, 1. Okay. Brr. All right. Now we have a 4 by 4. The last row has only one non-zero entry, that's 1. So what I'm going to do, I think I'm going to come up here and erase this one. I hope I haven't made any other errors, because once I erase this, I'll never find where those errors were. I think we're okay, though. Okay. I think I'll get rid of this, too. Okay. All right. Now, that's the positive entry. Plus, minus, plus, minus, plus, minus, plus. Okay? So it's 1 times the determinant. So the determinant of A is still, because the row or column operation, multiplying a row or a column, multiple of one adding to another. That doesn't change the determinant any. So this is going to be wipe out this row and that column, and it's the determinant of what's in there. Okay? Well, before I do anything else, what happens if you add row 1 to row 2? So let's just do that as another step then. Okay, if you add row 1 and row 2 together, row 1 plus row 2. Okay, then this will produce this matrix. Using row 1, so it's going to be 8, 1, 3. Okay, 0, 0, 5, and a 13, 5, 6. All right. Now, let's do the determinant. The determinant of this matrix is this 5 is in a negative position, plus, minus, plus, minus. That's going to be a minus 5, so the determinant of A is going to be minus 5 times this. That would be 40 minus 13. 27. And that will be minus 135. All right. I'm so glad to see you. I get so sick of talking to myself. I don't make very interesting conversations. And happy Halloween. Okay, this is, Kimmel's not here yet, but Jasmine is. Okay. What's that? Oh, yeah, flip them, yeah, I'm sorry. Oh! Yeah, and turn that one on. Yeah. That might add a little light to see. But it doesn't mess up the board much. Okay. Let the board come up. Oh my goodness, I got it right. Shoo. I was thinking I'd made another dumb mistake. Now, you're not going to be able to follow everything I did because I've had to erase to keep, although this will have a big enough screen to write on. This was one sort of advantage when I was doing everything on the board. I could show every step in there. And if you're in here with me, you get every step, but if you come in like this, you'll miss a few. I'll just explain what happened here. This is example 6, top of page 117, section 3.2, determinants of elementary row operations in chapter 3, which is determinants. And here's a matrix A that we started with, 5 by 5 matrix. Okay? Now, we want to find the determinant of that. Now, using just the cofactor and the minors and those kinds of things from the previous page, you found out this is going to be, if you did it that way, you would have about 324 operations to do if you just did it cofactors and stuff. Now, you have some zeros in there, so that would save you a little bit of that. But using row reduction, you're down to 75. And using smart row reduction, you can maybe eliminate some more. So I looked at the matrix, and basically what I look for is how many zeros I can find. There are 3 zeros. 1, 2, 3. This one's sort of isolated, not really helping with some rows with big numbers, columns with big numbers. But look, these two are in the same column, and look at the other numbers in that column. Very easy to do row reduction here to get some other zeros here. So I used the second row, added it to the fourth row, and got, that was the one that was over there I've already erased. But that gave me a 0 here. And then negative row 2 plus row 5 gave me a 0 there. Well, I've already erased that. Sorry about that. Okay. The other good news with this, though, is when I did negative this plus this, that gave me a 3, a 0, a 0, a 0, and a 1. So I wound up with another matrix that had 2 zeros in one column. Okay, so I looked at that and said, hey, look at that. With a column elimination, I can make this a 0 too. So negative 3 times column 4, add it to column 1, and that gave me this. Okay? Made these numbers bigger, but it gave me something fairly simple there. Well then, this will be the determinant of this thing. And remember, you got 3 elementary row operations, right? Swapping 2 rows, that negates the determinant. Multiplying or dividing a row or a column by, and swapping 2 columns negates it too. Multiplying or dividing a row or a column by a number, other than 0, of course, will then multiply or divide the determinant by that same number. Okay? But when you add a multiple of one row to another row or one column to another column, it doesn't change the determinant at all. So that's all we're doing, is doing these kinds of operations so it doesn't change our determinant. And this kind of operation doesn't change our determinant. So basically then, the determinant of this is the determinant of that, is the determinant of this. Well, looking at this, the determinant of this, like on this row, this is a positive entry here, and that gives me the determinant of this. Well, looking at the determinant of this, look at that. If I add this row 1 to row 2 here, I wipe out these two. And that gave me a 813, 005, when you add these together, 005, and then 1356. Okay? Well, the determinant of 8 is that determinant, and for some reason my first line didn't show up there. Well, I could do this determinant pretty easily. Okay, first thing I do, I'm going to take this entry, we're going to do this row here. This entry over here is a plus, minus entry. So it's minus 5 times the determinant that's left over when you wipe out that row and that column. And that's going to be this minus that. Well, 8 times 5 is 40. Minus 13, that's 27. Negative 5 times 27 is negative 135. And if you look at what the book did, they got negative 135. Took them a whole page. It took me a few erasures here to do it. And we didn't quite do it the same way, but we did it awfully close. They eliminated the top row rather than the middle row. Doesn't really matter. Okay. So sure enough, negative 135 is your determinant. And it's pretty nifty. If you can figure out what best to eliminate, go for it. All right. That's a lot less than 500 or some odd operations. No, 300 some odd operations. Okay, homework exercises here. That finished 3.2. Oh, this computer is warming my hands by it. Okay, do any of the odds 1 through 19. And by the way, this author does calccheck.com for worked out solutions to odd number exercises. So they're all there. If you get stuck and can't get the answer in the back, the odd numbers have the answers in the back. If you can't get the answers they do, then go to calccheck.com. And you can't figure out why you missed it, go to calccheck.com and you'll be able to see it worked out. Okay, do either 21 or 23 or both. Any of the odds 25 to 35. And then there's a true-false. Multiple statements in that, 37. Not a bad idea to look at that. And then either 39 or 41 or both. Those are a little bit different. 43 is a proof, so you can look at that if you want to. 45 is a pretty simple problem. It has two parts. And then there's a guided proof for 47, and that's it for that section. So let's move on to 3.3. Any questions on 3.2? All right. 3.3. Properties of determinants. Okay? In this section, you'll learn several important properties of determinants. You will begin by considering determinants of the product of two matrices. So, let's clear our ink. And let's look at two matrices. A is a 3 by 3, 1, negative 2, 2. And if you had been in here when I was doing that one, I actually copied something wrong in that 5 by 5. And fortunately, I looked down and said, hey, something's not matching up here. And I found out I'd left off the sign when I copied the problem down and made a -1 a 1 or vice versa. I don't remember. I think I forgot to put the minus in. And it almost cost me the whole problem, but I saw it in time to catch it. So be careful. And then I found the arithmetic error that I made too before it cost me too dearly. Okay, there is matrix A. I hope I got it right. And here's matrix B. 2, 0, 1. 0, negative 1, negative 2. There, I did it again. I said negative 2 and wrote a positive 2. 3, 1, negative 2. All right. I hope I got it right. Now, yuck. Goodness, I'm cold. It says find the determinant of each of those matrices and then the determinant of the product of the matrices. Well, the determinant's not going to be too hard. It is a 3 by 3. We could expand it, but since we got some zeros in there, it's easy not actually expanding it. So, what would you suggest? Where would you begin to get the determinant of A? First column would be perfectly fine. First column or third row, both of them are very, very easy. Okay, I like first column, so we'll go with it. Okay. Now you could do a row reduction if you wanted to, but it's pretty easy to do this way. So let's do first column, and you first are going to do, first entry is a positive 1, so that's just going to be 1, positive position 1, and times the determinant is here, and that's just going to be 3, right? Because minus 0, right? Okay. Plus, and it's a plus because you're skipping the second row and going to the third, which is also a positive position, so that's plus 1. And let me erase the stuff that might be confusing. Okay, we're going to the third, so we're going to wipe out still the first column, but now the third row. And its determinant is negative 4 minus 6. So that's a minus 10. So 3 minus 10. Is equal to negative 7. Okay? Good. That's what they got. Yeah, because 0 times this determinant is just going to be 0. Okay, so then you go to this one, that's a 1 also, so I didn't even write down the 1. How's that determinant? That's going to be a negative 4 minus 6. That's negative 10. 3 minus 10 is 7. Okay.
You have to multiply those numbers.
Yeah, right. Yeah. All right. Let's look at matrix B. And we're going to do the determinant of B. First row, first column would be good choices, or second row or second column would be good choices. Okay? Second column? I like that too because it has the smallest numbers. Okay? So, and it doesn't really matter where you begin. Which one you want to go for? Yeah, the second column. Okay, we'll wipe that out. But okay, you're going to start with okay. So that's going to be a minus 1. Okay, you first look and see what position that is, what sign of that position is. That's a positive position, so it's plus minus plus, plus minus plus. Either way, it's a plus. The diagonals are always plus, by the way, on square matrices, okay? So that's going to be a plus, a minus 1, so that's going to be a minus 1, and since we're using that one, we will do the determinant that's left. That's a minus 4 minus 3, so that's going to be a minus 7. You buy that? Okay. All right, then I'm going to wipe out that little line that I drew through the second row, and I'm going to put now the third one. Okay? Now this one down here is in a negative position. Plus, minus, plus, minus. So that's going to be a minus 1, again, but for a different reason, times the determinant that's left over here. And that's going to be a minus 4, and the other is going to be a 0. So that's minus 1 times a minus 4. Okay, so what do we have here? 7 plus 4 equals 11. You see how that works? Okay, and that's what the book got good for them. All right, the next thing we're going to do, for right now, I'm going to wipe out all my little marks here. I got to make sure that when I'm erasing the marks, I don't erase a sign too. I don't think I did. Let me just check it real quickly. I think it looks good. All right, the next thing they ask for is to get the product of AB. So we're going to do the product of AB. Oh, we remember how to do this, don't we? Okay, how do we do that? What size is that product going to be? A 3 by 3. Okay, I like to go and put them in so that way I keep track of what I'm doing. Okay? This entry here, this number is 1, 1. So you'll do the first row of A by the first column of B. So that will be is 8. All right. So that one's an 8. All right. Next is a 1, 2. So the first row, second column. 0, 4. Okay. It's looking a little bigger, but I guess the comes with multiplication. And then the third is going to be the 1, 3. So first column by third. First row by the third column. 5. Okay. So again. Yeah, so it comes out 1. Okay. All right, the number went down there, so good. Okay, the 2, 1 entry, the second row, first column, which is 0, 6. Okay. All right. Can you do it without me standing there? Say again? Negative what? Right. Negative. Is that what you said? I couldn't hear. Oh, okay, good, okay. So negative 1. Okay. I'm getting very few zeros. That's so disappointing. Okay. What's next? Yeah. What does that come to? 10. Okay. All right. All right. And then? Got it?
1, 0, -2, -1.
-1. Fantastic. Okay. Now, there's our matrix. Now the question is, what's the determinant of that matrix? It's not very pretty, is it? I guess in
Do you have to do anything to the matrix before you do the determinant?
no, there's nothing you have to do unless you want to do some row reduction or something. And that's what I was looking at. Is there anything easy to row reduce? If I were going to row reduce, I might take this one and add it to that and get a zeros there. And then actually I think I would take this one, add it to this one, and get a 0 here, and 5 times this to add it to that, get a 0 there. And then it would be a pretty easy thing to do, I think. You want to do that, or you want to just, you could expand this, you know, and then do the diagonals like we got. You know, there's several things you've got the choice of doing. What would you like to do? Do the what? Right. And just go it and do determinants from that? Yeah, let's do it. Which row or which column would you like to choose?
I would say either the
Second column? Is that what you said? Yeah. It actually has the smallest numbers in it. So let's go for that. Okay. My pen gets so tied up, the string is so tangled. Okay. So we're going to use the second column here. Okay. Now, so the determinant of AB would be, you want to start at the top? Okay. What position is that? Negative. So it's going to be a -4. So we'll wipe out the first row as well, and then we'll do the determinant that's left. Would it help me to write down that determinant, or you want to just go on and do it? Do it. Okay, that would be a -6, right? Minus a -50, so that would be +50. So -6 plus 50 is plus 50, 44, right? Okay. All right. Now I'm going to keep the keep the second column marked out. All right, we're going to the middle entry, which is the -1. That's a positive position, but the number is a -1, so it is a -1 times the determinant that's left there. And that would be a -8 minus 5 is -13, right? Okay. All right, then we'll wipe out that one. Okay. Going next to the third entry, huh? That third one down there, and what position is that? Negative position, so that's going to be a -1 times second -80 minus 6 is negative 86, right? Okay, so let's do that math, okay? Negative 4 times 44 would be 16, 17, negative 176, plus 13, plus 86, okay? Well, 18 and 36 is 99, isn't it? And minus 176 is what? Negative 77, exactly. Negative 77. Okay, so that's the determinant of the product. Now, let's go back and look at what the determinants were here. A minus 7 and a plus 11. Guess what? If you multiply the determinants together, you get the determinant of the product. Ha! Okay? So, that is an indication of what we've got doing. And let's see if the next theorem states it. And I think it does. Let me erase. Can I erase all this? Okay. And the Theorem 3.5 says the determinant of a matrix product, okay, if A and B square matrices, they've got to be, or else you can't do a determinant of them anyway, of order n, they've got to be the same size, okay, then the determinant of the product, AB, of those two matrices is the determinant of A times the determinant of B. I don't like to use the DETs. It takes too big to write. Okay. Now, they do have a proof there, which really, there's a lot more words than it is numbers and calculations, but it does have some. But anyway, if you want to go through the proof, it's there. Now, goodness gracious, I'm cold. Let's go on and do Theorem 3.6. Okay? Since we're here. If A is a square matrix, okay, of order n, okay, and C is a scalar, any number you want it to be, generally not 0 though, okay, then the determinant of CA is the determinant okay. The determinant of CA is C to the n times the determinant of A. All right. Now, you might say, why did C get raised to such a big power? C to the nth power. Okay? Well, if you think about it, what does multiplying C times the matrix do? Multiplies every element in that matrix by C. Every one of them. So now what are we going to do? Take a determinant. And the determinant is taking this value times those values. Every time you're multiplying by n's. Okay? So you're going to do this C times C times C, C times C, adding this. So yeah, you're doing C cubed. Because that was a 3 by 3. It's a 4 by 4. You're doing C to C to C to C. You're doing 4 times that. So sure enough, that is C to the n times the determinant of the product, scalar product times the matrix. It's going to be that scalar raised to the nth power times the determinant of the matrix. And they do a little proof there, and it uses one of the properties of 3.3, which is a few pages back. All right, let's see if we can get an example with this, okay? All right, to erase this? Okay. Okay. Here's a matrix A. They love matrix A, don't they? Okay. 10, negative 20, 40, 30, 0, 50, negative 20, negative 30, 10. All right. Burr. Now, what's one thing you notice about that right off the top? That everyone's a multiple of 10, including 0. So this is the same as 10 times the matrix, and what matrix would you have then? All right. Negative 2. And negative 3 and 1. Okay. Now, that's a lot easier to do a determinant of that thing than the determinant of this one. Numbers get quite big. So, now instead of find the determinant of A though, so the determinant of A is going to be, and what size is A? 3 by 3, so that's going to be 10 to the third, because that's your n, times the determinant of this thing that we have here. So what is the determinant of that? How would you do that one? Okay, you could, but I'm really lazy. I like to find the zeros. There's 1 0, and that's the second row and second column. So I'm real tempted to go with that. Okay, so is that all right with you? Second column, I like that best. Okay, so this will be, the determinant of that thing is, oh, I shouldn't use that symbol. Let's see. I'll just use a big parentheses. Okay. So we start with, we're going down the second column. Okay. And where do we begin there? Okay, it's a negative position, so it's going to be minus a minus 2, so that's just going to be 2. And we'll wipe out the first row because we're using that 2, and it'll be the determinant that's left here. Yeah. Okay. 3 minus or minus 10, 2 times 13. Okay? What's that? Right. It's a minus because this is a negative position here, but you got a minus 3, so that's going to turn out being a plus 3. And when I wipe out that row in that column, what do we have left there? Negative 7. All right. All right. 10 to the third times 2 times 13, 26 minus 21, 5,000. God. Okay. Okay. So we got 5,000, and that's exactly what they got. Okay. So theorems 3.5 and 3.6 give formulas for the determinants of the product of two matrices and a scalar multiple of the matrix. These theorems do not, however, give a formula for the determinant of the sum of two matrices. Sum of the determinants of two matrices usually does not equal the determinant of their sum. That is, in general, after the determinant of A plus the determinant of B is generally not the determinant of A plus B. Okay. All right. Okay, let's just do this one little aside that's down here at the bottom. It won't take long, I don't think. Here's matrix A. Yuck! Okay, here's matrix A. Simple little matrix. 6, 2, 2, 1. Matrix B, 3, 7, 0, negative 1. Okay? Let's do the determinant of A. Pretty easy, isn't it? What is it? What? 6, yeah, 2. And the determinant of B is what? Negative 3. All right. Now, let's do A plus B. What would that be? A plus B. 9. 9. 2. 0. Okay. Now let's do the determinant of A plus B. Negative 18. They have anything to do with 2 and negative 3? No. Okay. So determinants of sums, there's no rule for that. Determinant of product, there is. Sum of the is the product of the determinants, but sums not. All right. So we will start next time at the top of page 122, determinants and the inverse of a matrix. And wipe out my other arrows here so I won't be confused when I come in. Okay, and we'll pick up and go from there. Homework exercises in this section. We made decent progress here. Do any of the odds 1 through 5, and any of the odds 7 through 11. And do either 13 or 15, or both if you choose. All right, and we'll pick up the rest of those next time. Good deal. And I did run over just a little bit, but not too bad. Made up for this morning. I let them go 2 minutes early. So, I'm just kidding. Okay, I don't usually do that.